I realize it's Friday, and AP Stats at the end of the day on a Friday is like, you know, fun for Evie. I know. She's excited about it. Everyone is so angry today. I'm taking pictures in my head of all these mean faces. Oh, it's not personal. I know it's something else happened. We probably shouldn't be recording this part, huh? Oh, well, here we go. It's all right. Just know that Mama Mac loves you. It's all right. We'll be okay. Here we go. Line of best fit. Are you ready? You should be. Get out your formula sheet for me, please. The one that I gave you last class that is in the page protector. You, like I said before, you will be allowed to use this at any time, on any test, any quiz, whenever. But what's the condition? Can't write on it, okay? And there's a reason for that, and I don't want you to take notes on it and give yourself hints because I want you to practice using it in the way you will see it on the AP exam, okay? So what we're going to be looking for on this formula sheet are these three formulas I have on the right-hand side here. Where is it? Which column is it in? Should be the first column, right? Kind of like midway through the first column. And I think hopefully I told you that this is not, I condensed this to one page. On the AP exam, it's actually 3 pages long because they don't believe in saving paper, I guess. I don't know. But these are the 3 formulas we're looking for. Let's identify what each of these variables are, okay? So the first one we've kind of referred to last class. What does the little hat mean again? Regression. Okay, so we know that that is the actual equation for the regression. We also know that when we write a regression equation, we're going to almost always put in the context, right? Put in what the variables are, put in the words, right? Now, what does, in this case, B naught represent? The y-intercept. I love that. Very good. Now, on your calculator, it uses, I think, A and B, doesn't it? So don't get confused. That B means something different than this B. Just pay attention to the number that's with the x, okay? And the number that doesn't have an x with it. The number that's with the x, in statistics, we denote that with B1, and it is the slope, okay? And I think it just depends, honestly, whether you choose, when you do your regression on the calculator, whether you choose option 1 or option 8, depending on whether it's an A or B. Don't worry about that part. Just worry about what is the number with the x, okay, the position. Now, we already decided that B1 is the slope, right? So this is how we find the slope. And this formula is how you do it. We just need to know what the letters are. And I don't believe they have parentheses on yours either. No, okay. So it's written just like this. Now, R stands for what? We should know that. Correlation, okay? So that is going to be the correlation. Sometimes you will be given the correlation, so you just plug it in, okay? Sometimes you'll have to find it. Now, what's kind of ironic is if you're going to find the correlation on the calculator, aren't you actually finding the line of best fit anyway? Okay, so I get that that's kind of like redonkadonk, right? Because it's already there, Miss Macker. I got the equation. I just need you to show me the work. Okay, showing you how you can use the formulas. So we know what the correlation, that's R. Now, SY, SX, how many variables are there when we do a linear regression? The whole unit is called bivariate. So how many variables are there? 2. So we have an X variable and a Y variable. Okay. So the S of Y and S of X stands for, what do you think? Standard deviation of the Y's. That's what SY stands for. And SX stands for the standard deviation of the X variables. Okay? Well, range is something we really rarely ever use. We kind of almost want to take that out of our head and store it off to the side. But standard deviation is a measure of spread. Absolutely. Okay? And it's how far the data is away from the middle, or the mean. I should be specific. But these do reference the standard deviation, okay? And in a minute, I'm going to give you a set of bivariate data, and you're going to calculate the line of best fit by hand, and you're going to find all of this stuff, and I'm going to show you how to do that. Now, down here, what does B naught represent again? The y-intercept. And the y-intercept is found using this formula. So we have to have the slope in there. But what does the y bar and x bar notationally stand for? The mean. So we have two different data sets, right? We have an x and we have a y. We're going to find the mean of x and the standard deviation of x. We're going to find the mean of y and the standard deviation of y. And that's what we get here. So SY, standard deviation of y, y bar, mean of y. Okay? All right, just want you to know what the numbers stand for. Now, in this particular case, I'm giving you what all of them are. Okay, question, Erica. Yeah, it's the mean of the x's, and y bar would be the mean of the y's. That's up here. Okay, so up here when it says S, so this is standard deviation, whereas these are the means. Two different formulas. Okay, good to go now? All right, so for the first time we're going to do this, I'm going to give you everything, and you're just going to come up with the equation. All right, so I've given you all the information over here that you need. Let's plug them in. You're going to need to find the slope, and you're going to need to find the y-intercept. Be careful, because you have to find one of them first. Which one are you going to have to find first? You're going to have to find the slope first. Why can't I start down here with the y-intercept? Because slope's part of the formula. Exactly. Because slope's part of the formula, so you have to find the slope first. All right, so I'm going to pause the recording for a second. I want you guys to try this, use your formulas, and then we'll go from there too. All right, so it looks to me like we had it right. Let me just double check for the most part. You first have to find your slope, so we're going to go ahead and do that by taking our correlation and multiplying it, write my correct notation, multiplying it by the ratio here, 3/2, and you got a slope of 3/4. 0.75 is fine, since it's an exact number, correct, Abby? Okay, we're going to do one next where it's not given to you, okay, because you're going to actually have to do it on your investigative task that I assigned last class, okay? You're going to have to use these formulas to do that. So that's what we're going to do. So we'll practice that. All right, the next one is the y-intercept. So the y-intercept would have been your 20 minus 0.75 times your x bar, which is 10, and you got that to be 12.5, correct? And then you just put things together, and so your equation of the line of best fit here is simply going to be 12.5 plus 0.75x. There is no context given here, so you can leave x and y there. Good to go? No problem. All right, so let's go to Evie's question. What happens if I give you a data set? I give you just some numbers, and I ask you to find the line of best fit, okay? So what I'd like us to do is I'd like to take out the investigative task that I gave you, and we're actually going to do one together. We'll do data set 1, okay? We'll find it by hand. And then I will ask you to do it for every other data set. B, I think, is it, did I call them 1, 2, 3 or A, B, C, D? A, B, C. All right, so we'll do A together, and then I will have you do this by hand with B, C, and D. Good enough? Okay, so data set A, and you're going to graph this on your own. You're going to create a scatter plot. After today, you'll learn how to make a residual plot, so you will know how to really do everything that's needed for the investigative task. Okay? So I'm going to borrow Sean's. I'm going to write the data set up here real quick. And the thing that I would ask you to do is kind of what Evie was saying, is that is your SX, SY always going to be given to you? And it's not always going to be given to you. So what we need to do is we need to be able to find them. And I am perfectly okay with you using your calculator to do that. I'm going to have to continue it down here. So we have 6, 4, 12, 7, and 5. Sorry, I didn't mean to steal your stuff here, but Sean doesn't mind, right? Uh-oh, I wrote that wrong. So what you want to do is plug these numbers into your calculator, okay? You want to go ahead, and the calculator will tell you not only the line of best fit, but it's going to give us the information that we need, the standard deviation of x, the standard deviation of y, the mean of x, the mean of y, etc. So take a second, if you would, while I'm writing this down, and go ahead and enter these numbers into your calculator. into list 1 and to list 2. Okay? Lindsay, I was trying really hard to get this calculator to show up on my smartboard, but it's not showing up. So if you're watching this, do me a favor and just plug it into the calculator, and then I'll kind of talk you through it. All right, so unfortunately, I don't have my calculator on the smartboard, so you can't see it, but I have entered the data into list 1 and list 2. So I have put this data into list 1, I put this data into list 2, and I literally just want to find all of these things. I want to find R, I want to find the standard deviation of Y, the standard deviation of X, I want to find X bar and Y bar. Those 5 pieces of information will give us everything we need to find the equation of the line of best fit. Do you agree? Okay. Huh? I don't know why I did 2 bars, because I did it wrong. Okay. Don't do that. Okay, thank you. All right, so let's go ahead. All you have to do is go to Stat, Calc, and we're going to go to 2 variable statistics. It just automatically does them both at the same time, so you don't have to do them individually. And it will go ahead and say our X's are in list 1, our Y's are in list 2. We'll calculate. And so we have an X bar of 9. We have a standard deviation of X of 3.32. Would that be good enough? And then we'll go and find our Y by scrolling down. Our Y bar is 7.59. And our standard deviation of Y is 2.03. So I'm almost there. I need to find one additional piece of information, and this is the part where it's kind of silly. Okay, Tanner? Stay at the game too late last night? What? You're listening. You're absorbing. You should be involved. Come on, wake up. You need some sugar? There's a blow pop right around the corner if you want one. Help yourself. I'll give you all blow pops in a minute. Okay? Hang tight though. Let's get through. So here's the part. You can just pass the box around. That's fine. Take one only. Okay? So we need this. Okay? Can you lift it up? Okay, just take one and pass it around. All right. Shh. Please don't let this be a distraction, or it won't happen again. Okay. So the one thing that we need is a correlation, right? Now here's the part that's kind of silly, because honestly, if we find the correlation with the calculator, isn't it going to give us the line of best fit anyway? Yeah. Okay. So I would say probably on an AP exam or something like that, they would probably give that to you. But because I'm asking you for it on this investigative task, I want you to practice using the formulas. So you'll get the correlation, you'll get the answer. So you can kind of just show me the work and make sure that it matches what the calculator gives you. What might be a reason that the calculator gives you a different line of best fit than the one we calculate by hand? Because what? Because I'm rounding. All of these values are rounded, so you're going to get, it might be a little bit off. It won't be too bad, but it might be a little bit off here or there. Okay, so don't panic about that. How do I find the correlation? Do you remember? Stat, Calc, 8. Love it. And then we just have list 1, list 2 in there. And we got a correlation of 0.803. Now, I probably would not round it to 0.8. Okay, I probably wouldn't round it, so 0.803 is probably as far as I would go with that. And then I would just plug these numbers in, just like we did before, and find the line of best fit. Now the calculator tells you what it should be. Do you agree? Okay, so what I'm looking for here is that you show me this work. Show me the calculations. Show me on each of these data sets that you went back and found the line of best fit using the formulas. Are we okay with that? Yes. 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 Any of the calculations can be done on a separate sheet of paper as long as you do all of A's together, all of B's together, all of C's. Does that make sense? Okay, yes. Eddie. Shh. For what, baby? Stat Calc option 8. Option 8 is Lin Reg, but it's just further down.
And
I press enter, enter, because list 1, list 2 should be X and Y, nothing in your frequency, and then just press calculate. Does R not show up? Your diagnostics might not be on.
Okay.
Yeah. So let's help Evie. Let's remind her, if your diagnostics aren't on, your R won't show up. So we need to make it show up. How do we remind, do you remember? Mode. I learned this year. This is my learning tool for the year. Go down to statistics, all the way down. Boop, 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 boop. Statistics, turn them on. The diagnostics on. Now redo it and it should work. You mean this one? Okay. All right, are we good to go now? All right, did it work for you? Good. All right, so you should now know how to find the line of best fit. We can't put these in context because they're just X's and Y's. So you can just leave them, make sure you put the hat on the regression, okay, because that's important notation. And then you just show me the equation. The graph on the scatter plot, you should be drawing the line of best fit on the actual scatter plot. On the graph of scatter plot, you should also include the correlation and the equation. We haven't talked about R squared yet, okay? I'm not sure we'll get to it today. Might be not till Tuesday, but your assignment's not due till Friday, right? Thursday. I'm sorry, Thursday. So that will be the one piece you don't have yet. All right, go ahead, Hunter. Question. Shh.
Our rubric says calculations with explanations. So how do we how do we give an explanation for R? Just so I work.
I'm looking for where it says that. Where do you see that, darling? Oh, along with explanations. I'm sorry. That just means like that's the section. So calculations would be the equation. Did you calculate using the equation? Okay. When I talk about explanations, I mean interpret the sum of the residuals. Interpret the conclusion. Write a sentence. You're not going to write a sentence for everything, but where it's appropriate, I want you to. Yes. I'm not requiring it to be typed up, but if you're Sammy Bonani and I can't read your handwriting, he better be typing it up. Okay. Erica. Mm-hmm. You need a calculator for this class. We are going to use it all year long. All right. Shh. Are we good to go now? All right. Put your assignment away now. Okay. I'm going to not give you anything additional for homework to work on this alone. Okay. Because it's kind of a big assignment, I think. So I'm not going to give you any additional homework, but I don't want you working on it right now in class. Okay. All right, what I need for us now to do is talk about how to create what's called a residual plot. And honestly, what we're really trying to determine in our investigative task is the answer to this question. Is the data linear? And that is really the big question, okay? So when I graph data set A, when I graph data set B, C, and D, you're going to be looking at these scatter plots and trying to answer this question. Is it linear, yes or no? And it's really, you have to kind of defend your answer with statistics. And the first thing you're going to look at is the scatter plot. Okay? So you will have to create a scatter plot and look at it. Does it appear as though the variables are related, going to form a line? Okay? So that's one piece of the information. 2, you're going to look at the correlation, because what the correlation measures is how linear the data is. The third thing you're going to have to look at is something called a residual plot. And you will need to do all 3 of these things for each of these 4 data sets, A, B, C, and D, in order to answer the question. Because I think on the rubric it literally says, is the data linear? Conclusion is reasonable. Do you see that? Okay. So I want you to decide on number 4. It says decide whether or not a line is a good model to fit the data. So you're going to have to answer that question, and you're going to have to support your decision with these 3 pieces of information. Yes, sir. Each of the data sets. Okay. So you're going to have to draw a scatter plot for each of them, a residual plot for each of them, and find the correlation for each of them, which you're going to do anyway because you're going to write the equation. All right, so again, when it asks you yes or no the data is linear, these three things have to be kind of to support it. We know how to draw a scatter plot. We know how to find correlation. Here's our missing piece. What in the heck is a residual plot? Okay, let's figure that out. We know what a residual is. We defined that last class. I think we even defined it 2 classes ago, quite honestly. What is a residual? Think about it. You can, from a graphical standpoint, it's fine. Tina? Okay. Yes, it is a distance, and it is away from the line. Let's add to that definition and be more specific. Okay, so the observed minus the predicted, that's the that was the, I think, the formula I gave you. Let's kind of piggyback on Tanner. What kind of a distance is it? Not going to say that? Okay, Zachary?
How far away the data is.
What kind of distance? Be more specific? It's vertical distance. Come on, give me a high five. It's Fun Friday, all right? Let's do this. Go, Judith. Woo, woo. Okay? Okay? Anyway. Lindsay, you're missing it, but the disco ball's going. Okay. Anyway. So yes, it's the vertical distance. Okay, it's the difference in the y values. Okay, between the predicted value and the observed, and it's really the other way around. The observed minus the predicted, right? So it's how far that data is. So what we want to do is we want to create a plot that's going to show those residuals together. Okay, so here's a data set that I have for us, and it should kind of look, whoa, that's pretty. Okay, here is, well, maybe not. The equation, I guess, is hidden. There it is. Woo, yay, magical. Okay, here is a line of best fit, and I faked the hat because I forgot to put it in when I typed it, but there it is. That is the predicted, the equation that you find. The regression equation is the equation that's used for the predicted values. Because we know, as Temerson said, that a residual is the observed minus the predicted, right? So, how do I find the observed value? You probably should write this down because this is what you're going to have to do on your, for each of the 4 data sets on your project. So, I have an x and a y. Okay, just like you have an x and a y for each of your data sets A, B, C, and D. Are you guys okay over here? What am I doing? Is my zipper down? No. Lindsay, they went a little cray-cray. I don't know what to tell you. All right, here we go. I stole Daniel's. Shh. So you are going to be given these data values, right? You're given an x, you're given a y. Just like on you're given your bivariate data set. We need to actually calculate the residuals, okay, by hand. And you need to do this as well. I believe it says on there, calculate the residuals. So you will need to create a little table like this to actually show me how you found the residuals. Okay? The calculator is kind of nice, and it will do that for us, but I'll show you that in a minute. Okay? So we need to we have our observed values, and we'll need to find our predicted values. How do I do that? How do I find the predicted value? Any ideas? Think algebra for a minute. Plug in what? Yes. So I'm going to plug in 1.5, so 7.1 minus 0.74 times 1.5. I'm literally plugging in 1.5 into my regression equation, right? And that's going to give me the predicted value. It's the value that's actually at 1.5. Let me scroll up for a minute. So 1.5, it's this value right here on the line of best fit. That's the predicted value. We're trying to figure out what that number is. Are we understanding what I'm saying here? Okay, so really quickly, we'll do that. 7.1 minus 0.74 times 1.5. And I got 5.99. Did you get that too? Okay. You should have gotten exactly that, because that's what I got. No, use 5.99. Okay? because if you actually look at the graph, it's not at 6, it's at 5.99, right? According to my graph, it's not exactly. All right, so how do I find the residual? What do I do with, what am I doing to find the residual here? Subtracting your observed minus your predicted. So 5.5 minus 5.99. And that is negative 0.49. Did I expect that residual to be negative? Why? Because the observed value, which are the points, right? The observed value at 1.5 is below the line of best fit. So I did expect that vertical distance to be a negative residual. Good. All right. So I'm going to give you a second. I'm going to stop the recording. I want you to find the other residuals for me. Okay? Go ahead and do that for me real quick. Quite honestly, just plugging in a number and showing a calculation is algebra 1, right? We're way past that. I am more interested in, do you know how to apply what you know? And that's really the whole purpose of this class, quite frankly. All right, so here's what you need to do. So Lindsay, pay attention. You're going to put L1 as your X. I'll write it right here, L1. You're going to put your observed, your Y values into list 2. The predicted values, what you will do is you will go up and you will highlight your L3. You're going to highlight this so that your cursor is up there and it's darkened at the top. Now you will tell the calculator what you want it to do. You're literally going to type in, once this is highlighted, 7.1 minus 0.74. And what am I plugging in for X? The numbers I put in L1. So you're going to tell the calculator, okay, I want to type in 7.1 minus 0.74 times L1. And it will populate your list for you automatically. Okay? So it's kind of like a shortcut. Okay? Now when I get to the residuals, so let me just kind of write those in there real quick. You can tell the calculator to just subtract your observed minus your predicted. So you can just say list 2 minus list 3. But where do I have to go to do that? Up at the top. Up at the top of L4. It should. I'll show you in a minute. So 5.9, 4.88, 4.88, 4.51, 3.4, and 2.66. Okay. Now to get our residuals, I will literally go to L4. I'm going to clear out what's there. And I'm going to go up to L4. Don't forget, it's not going to work unless you are at the top of L4 and have the L4 darkened. Because you're telling the calculator, I want you to do this for the whole list. Okay? So once you're there, what is the residual? It's really L2 minus L3, isn't it? Because it's your observed values, which are in list 2, minus your predicted values, which are in list 3. So it's L2 minus L3. Now, where are these L's again? They're second 1, second 2, second 3. And it will populate those values for you as well. So negative 0.49, negative 0.88, 1.12, 0.49, 0.6, and negative 0.66. You probably should double check that if a residual is negative, you expect it to be negative. If a residual is positive, you expect it to be positive. Just by looking at the graph, you can make those determinations. Based on what we did last class, what should the sum of these residuals be? 0, or at least very close to it. Could be rounded, some rounding issues, but it should be very close to 0. Now, I've had some time, in the years past with my statistics students, you might get a sum with, when you sum on the calculator. Do you know how to do that on here, by the way? A quick sum of all the numbers? Yep, so you just go to, you quit out of this, and you just go to math. Is it 0? I don't think, oh, summation. No, that's summation. I go somewhere else. I go to list, math, and then sum. Okay? And you're going to sum. The residuals were in list 4, and so I got close to 0, right? Not exactly, but close, because of rounding, and that's okay. Sometimes on here, what you'll get is you'll get like an E that shows up. Do you guys know what that notation means? Yeah. It's scientific notation, really. It means the exponent of negative. Just treat that as a 0. It's to find the sum. Okay, so to find the sum of the residuals, so the sum of L4, you're going to go to list, which is second stat. And then you're going to arrow over to math, and then you should see the sum key. Okay, and so it should just quickly find the sum for you. Again, using technology to help us get where we need to be. All right, so I have the residuals. Yay. What do I care about that? Well, we need to make a residual plot. And what we're going to do is we are going to make a plot. It's going to be kind of a scatter plot, but it's not a true scatter plot. Oh, I knew that was going to happen. There we go. Let's make a plot between the x values and the residuals. Okay? And this plot and the shape of the plot is going to be the third piece of information. Is the data linear? So you have to kind of do all of this to get to the residual plot. So go back to the stat plot. Okay, you want to go to y equals. There better not be anything in there. Other classes use these calculators, so if you're using mine, nothing in y equals. We want to go to your stat plot. We want to turn it on. And we want it to be a scatter plot type, but we have to be careful. We don't want to create a traditional scatter plot. That would be list 1 versus list 2. That's your scatter plot. I want to create a residual plot. And a residual plot is from list 1 to list 4. It's your x's versus your residuals. Okay? So we're going to change our y list to be list 4. Okay? And then we'll zoom stat and get a nice picture. And this is the residual plot I get. Okay? I'm hoping that it showed up. Oh, this is, by the way, calculator steps. Yay, fun. Okay. Oh, that was a different one. There's a quick way to get the residuals too, but I didn't show you that. Will, but not now. All right. I didn't, I guess, actually show the residual plot. Awesome sauce. Okay. So here is what the residual plot looks like. Approximately looks like that, right? Sketch. What we are looking for in a residual plot, in order for the data to be linear, remember we're asking this question, is the data linear, right? That's the question at hand. So it's a yes or no question. 1, does a scatter plot look like it's going in a line? 2, is a correlation strong? The third piece, we're looking at this residual plot. If the data is linear, yes, the residual plot will have no pattern. This is something you definitely should write down. Okay? This is something that you will see over and over again. If the data is, so yes, the residual plot has no pattern. If the data is not linear, then guess what the residual plot's going to have? A pattern. And there are a couple of different patterns that we will discuss. Okay? And you will see some of these patterns when you analyze those 4 data sets in your investigative task. Because when you, what the residuals do is minimize the vertical distance, right? That's what the line of best fit does. So if the line of best fit is not the regression equation that should be used, then those vertical distance aren't going to be minimized, which means if you plot the x's versus the vertical distance, you're going to get a pattern of some kind. It takes a second to wrap your brain around that for a little bit, but just go with me on the fact that when you plot your residuals, you want them to be as randomized as possible, okay? So let's look at what some options would look like. Here we go, okay? We have a couple of different residual plots here and here, okay? On the left, I have an example of a linear model that would be appropriate, okay? I have kind of a random scatter in my residual plot, and that's what I'm looking for. In a residual plot, I'm looking for a random scatter. Over here, I have a residual plot that really kind of might have a pattern to it. It looks to me a little bit like it's kind of got maybe a little U-shape, sort of. It's got some kind of pattern going on. Now, some patterns are called fan patterns, and that's something that you need to be able to see as well. If you know anything about higher level mathematics, it kind of looks like a, I'm trying to think, I think it's, now I can't remember it. Hang on, I'm sure Devin will tell me. What is this called? Think about when you graph a sequence, what kind of sequence is it? Divergent sequence, sorry. Yeah, divergent sequence, right? So when a sequence diverges, if you don't know anything about that, don't worry, but if it goes off into two different directions, it doesn't converge, but it diverges. This is called a fan pattern. If your residual plot has a fan pattern to it, we call that's a pattern, okay? So that's definitely a pattern to it. It won't be exact, but this is called fanning, a fan pattern. And so that's something you want to look out for, okay? U-shapes, you really just honestly want a complete random scatter. A random scatter is a good thing when it comes to a residual plot, okay? All right, so let me make sure. Is it appropriate? Are there any, we talked about outliers. Okay, so in order to answer the question, I'm going back here, is the data linear? You should know now how to do all three things. Do you agree? You know how to make a traditional scatter plot. It's just your x versus your y's. You know how to find the correlation. You know how to find the equation of the line of best fit, because you need to do that to find the residuals, right? And then you know how to now create a residual plot. Do you agree? Okay. So